What's up? Still me, the great teacher, here for another video. And all we have to talk about here is segment lengths of chords, secants, and tangents. Let's just jump right into it. First off, we have theorem number 1. If two chords intersect inside the circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. As you can see here in this circle on the left side, we have AE as the first part. And if you multiply that to EB, it's going to be equal to the answer when you multiply CE and ED, their measurements. So to try that, we have the example on the right. And here we're immediately starting with complicated concepts so that you guys will be able to understand it better. So let's say that we have the formula again here. We multiply, for example, 4 to what? So 4 is partners with this one right here, so 4 times x, and it should be equal to this one times this one. So we will have here 6 times x minus 3. Doing so, if you continue here, 4 times x is 4x. Then when you have something like this, you have to distribute 6 to the given, so you're gonna have 6x minus 18. And the goal here is to find the value of x so that we can get the lengths of each segment. So what we do here is we can transpose or transfer or apply the properties of equality by subtracting 6x to both sides. Either way, it will arrive with the same answer. 4x minus 6x is equal to negative 18. 4x minus 6x is negative 2x, equal to negative 18. And to finalize this, divide both sides by negative 2. And the answer for x is equal to 9. So the 9 right here is the value of x. We can substitute that here. So x is equal to 9. While for the other one, it's x minus 3. So this is 9 minus 3. The answer is 6. So if you want to check out if the theorem 1 works for this, we can apply the formula saying we have 4 times 9. This should be equal to 6 times 6, and guess what, 36 is indeed equal to 36. So what I'm showing here is just a checking so that you'll be able to follow through with the concept for theorem number 1. So this formula only applies if you have two intersecting chords inside the circle. Next theorem will be for two secants intersect in the exterior of a circle, then the product of the lengths of one secant segment and its external segment, it's equal to the product of the lengths of the other secant segment and its external segment. So this one might be tricky for some, but basically, first off, we take note of our entire secant segment and then its external. So if you multiply those two things, their measurements, it should be equal to the other second segment it's connected to and its external. So again, they should be connected at an external point. That's the important thing that you have to remember here. So we have the example on the right. So the entire thing here from 10 to 6, 10 and 6, what I mean, so 10 plus 6, that will give us 16. That's the entire second segment. As for the external, it's just 6. Following the same concepts, this is x and this is 2x. Adding the two things, x plus 2x, that will give us 3x. And the external is 2x. So 3x times 2x. So 16 times 6 is 96. 3x times 2x is 6x squared. Divide both sides by 16. This will be 16 is equal to x squared. And to get the value of x, get the square root of both sides, our answer is x equal to 4. So if you want to check that, you simply have to substitute. So this one will be 4. This one will be 2 times 4, basically 8. So if you want to check that out, using the formula, we can have 16 times 6 equal to 8 plus 4 is 12. Then the exterior is 8. And as you can see, 16 times 6 is 96. 12 times 8 is also 96. So again, we're just doing the checking so that you guys can verify that what we're doing here is correct. Next one for theorem number 3. So if theorem number 3, the last one that we're going to discuss here, we're now talking about a tangent and a secant segment that intersects at the exterior of a circle. So similar concept from what we had earlier. For the secant segment, we still have the entire thing times its exterior. As for the tangent, we get the square of it. So now, doing this, based on the example that we have here, we're supposed to have 10 plus x, because we cannot add a number and a variable. We cannot do that. So we just simply combine them as a binomial. Multiply it to our exterior, which is x, and it's equal to x plus 4, because that's a measurement of the tangent raised to 2. So first off here, we distribute x to the given binomial. We're going to have 10x plus x squared. Here, x plus 4 raised to 2, this binomial raised to 2, the answer here is going to have a square of a binomial. You can do FOIL method if you want to. We're going to have x squared plus 4x plus 4x plus 16, or basically that will be x squared plus 8x plus 16. It's going to be a perfect square trinomial. Sorry if I'm fast forwarding a little here, because these skills are expected for you guys to know already. If you guys find that confusing, again, you may either apply the FOIL method or the concept of a perfect square trinomial. Now, what we have here, let's combine like terms. We can do this fast by transposing two things, because we have the like terms here. We can have x squared minus x squared plus 10x minus 8x, and it should be equal to 16. So 2x is the only one left here, because x squared minus x squared is 0. 10x minus 8x is 2x, equal to 16. Divide both sides by 2. Our x is equal to 8. So in this case, this would be 8 plus 4. This will be 12. This will be 8. So if we want to check that, we have the whole thing as 18 times the exterior, which is 8. It should be equal to 12 raised to 2. And 18 times 8, that will give us 144. And 12 squared is also 144. So our answer here is correct. As simple as that. We don't have to overcomplicate concepts like this. We just have to stick with the formulas. Remember, as simple as this one. So the tangent measurement will be raised to 2. For the secant, the entire thing times the exterior. So let's have an example wherein we combine the concepts that we had earlier. So what if you have two missing variables here? It doesn't have to be complicated. All you have to do is stick with the formulas and identify which one will be necessary for us to answer these things better. Because you have here, you're missing x and y, and you have to know which one you should apply in order to get one of them. So the best thing to apply here, first off, is the concept with the chords, because the only thing missing there is x. So when you're given two chords, it's stated that the segments of each chord, if you multiply it, it's going to be equal to the measurement of the other segment of the chord that it intersected. So x times 4 and 2 times 10. X times 4 is 4x. 2 times 10 is 20. Divide both sides by 4. Our x is equal to 5. So therefore, this x is 5. And now, we can actually apply the other concept. This time around, the difficulty here is that what is the other theorem that we're going to apply? Well, we're now going to work on given a secant and a tangent. So the thing here is that you have 5, you have 4, and you have y. If you add all those things together, the result will be as follows. So what if you are given with a secant and a tangent? So for the second, that's 5 plus 4, that's 9. But you cannot add 9 to y, so you'll simply have 9 plus y. And the y is the exterior, so 9 plus y is times y should be equal to the square of your tangent measurement. So just like earlier, distribute, this will be 9y plus y squared equal to 36. So here, as you can notice, we cannot combine like terms. So the thing that we have to do here is to actually maximize the use of quadratic equations. So let's transpose 36 to the other side, and let me rearrange it also. We're going to have y squared plus 9y, and 36 was transposed, it will be minus 36 equal to 0. And what we're going to have to do here is to find the roots of this quadratic equation in order for us to get the values of y. So you can do this in different ways. You can maximize your calculator or apply factoring or the quadratic formula. So applying factoring, we know that the factors of y squared is y times y. Now, negative 36 is our last term, so one should be positive, the other one should be negative. So what are the factors of negative 36 that if you add them, that's going to be equal to 9? So the answer there will be positive 12 and negative 3. Doing so, we now have the binomial factors. We equate them to 0. We're going to have y plus 12 equal to 0, y minus 3 equal to 0. And then, let's transpose. So have y is equal to negative 12 and y is equal to positive 3. Remember, these are measurements. And in this context, y is the measurement of the external segment, so it cannot be negative. So the answer we're going to have is 3. So again, just like earlier, if you want to verify if these things are correct, all we have to do is to use the formula and substitute. So let's see if this will be correct. So now, given two chords earlier, so this will be as simple as 5 times 4 should be equal to 2 times 10. The answer here is 20 is equal to 20, which is correct. While for given a secant and a tangent, you have 5 plus 4 plus 3, that will give you 12, times the measurement of the outside, which is 3, and it should be equal to 6 raised to 2. So this is 36 equal to 36. So it is indeed correct. So as simple as that, all you have to do is to know which theorem to apply first, followed by verification, just to make sure that everything else is correct. So let's have our last example. So let's say we have here as follow this image. So we have to know first which to apply. What we have to apply here is for our secant and tangent. It's the easiest one to apply here. So let's start with that one. So this kind of example can actually answer it in different ways. I'll leave the other way to you guys so that you can think of it. So let's try this one first. Given a secant and a tangent. So our entire secant here is x plus 2 times external, which is 2. And the tangent should be 10 raised to 2. So by distributive property, 2 times x, 2 times 2. So you have 2x plus 4 equal to 10 squared, which is 100. Let's put 4 to the other side. We'll have 2x is equal to 100 minus 4, or 2x is equal to 96. Divide both sides by 2. X is equal to 48. As quick as that. So this will be 48. If you want to verify that, what's 48 plus 2 times 2 is equal to 10 raised to 2. We're going to have 50, right? Which is the actual measurement of the entire second segment times 2. And that will be 100. So it's indeed correct. As for the last one, you can answer this in two ways. Either you use the secants, or you use this secant and this tangent, because it still applies. Your choice which one. But this time I'll choose given 2 seconds. So we had earlier 48 and 2, that's 50 times 2. and it should be equal to 21 plus y times exterior, which is y. So this is 100. This one will be 21y plus y squared. So I'll just fix this entire equation by transposing 100. So you'll have y squared plus 21y minus 100 equal to 0. So if you get the factoring of this one, you have to think of factors of 100 that if you combine, negative 100, that if you combine, it's going to be equal to positive 21. Just like earlier, we know that y squared is y times y, negative 100, but equal to positive 21. So one is positive, one is negative. So the factors here, positive 25 and negative 4. So equate them both to 0. Y plus 25 equal to 0. Y minus 4 equal to 0. Y is equal to negative 25. And the other one is y equal to 4. Let's take the positive one. So y is indeed equal to 4. If you want to verify that, what we can do here is 50 times 2. 21 plus 4 is 25 times 4. And the answer is both 100. So it's still correct. Just like that, we're able to finish finding the values of x and y using the given chords, secants, and tangent segments. All you have to do is to maximize the formulas and to know what secants are, what chords are, and what tangents are. That's basically it. And that ends this video. My god, that clap hurts. God, even my grammar is not working right. I broke this finger because of the Wii jump thing. I don't know. My friends asked me to join them yesterday, and I'm also sick. I also have a sprained ankle, probably, hopefully, sprained ankle. So yeah, I've been struggling to do these things, but yeah, what a life, right? What a life. Anyway, we only have a few. Yeah, so that's sad to say, but we only have a few videos left in the tank, so we're gonna enjoy them. I'm gonna make sure to somewhat show them in a different way, why not try to be great also with the video making. We'll see, I don't know yet, but I'll try to find a time to make these videos different the last few months. So stay tuned for that. And again, in case you don't see me, good morning, good afternoon, good evening, and good night. Peace out, guys. Respect.